Welcome and thank you for attending the first HEAT Roadmap Europe webinar. I am John Kapetanakis, part of the HEAT Roadmap Europe team at Aalborg University in Denmark. As part of the project, Aalborg University will be hosting a series of webinars about the multinational project HEAT Roadmap Europe, funded by the European Union. There are 7 webinars scheduled for spring 2018, and more will follow in autumn. At the webinars, project partners will speak about methodologies and findings of HEAT Roadmap Europe. On our website, you can find more information and register for free to the webinars to come. Next to me is Vad Mathiesen, professor at Aalborg University and coordinator of HEAT Roadmap Europe, main speaker for this first webinar. He is going to introduce you to the project and set the scene for the webinar series. After his presentation, we will have some minutes to address questions or comments you can send from the GoToWebinar sidebar on the right of your screen. Brian, the microphone to you.
Hello, everybody. I am Vad Mathiesen, and I'm going to speak to you today about roadmaps to decarbonize the European heating and cooling sectors. And as you all know, the main focus here is the project called HEAT Roadmap Europe. This is the first of about 14 webinars, where some will be held here in the spring and some in the fall. We will try to bring you some of the results that we have already achieved in the project, but also perhaps tell you a bit about what you can expect in the coming months and half to a whole year from our HEAT Roadmap Europe project. One of the main challenges we have is what is actually the role of buildings in the future. I guess all of you who are listening are wondering about some of the elements about the technologies and the policies needed in these sectors. So we're going to try and talk about what is the role of buildings in regards to renewable energy systems. Is the solution net zero emission buildings, passive or plus energy buildings? How important is actually the heating and cooling system in my city, my country, or at the EU level? And I hope in HEAT Roadmap Europe we can illuminate some of these and quantify this. How much effort should we put into energy savings? How much effort should we put into energy efficiency? And what is actually the balances between energy savings, energy efficiency, and the energy supply system? Other questions could be, how should we actually heat the houses in the future when we want to use renewables? Is it heat pumps, gas, electricity, hybrid heat pumps everywhere, or is it a multi-technology solution that we're looking for? Is district heating fit for the future? And should we have more of this, or should we have less of this? If district heating is fit for the future, how do we actually put in something renewable into these infrastructures? And also, of course, who should do what we need to do in the future? So these are some of the things that I hope that we can illuminate and bring you some knowledge about. First of all, the heating sector is significant. In this slide here, you see the 2015 heating and cooling demands for the European Union compared to the final energy demand. And as you see, it is around half of the total final energy demand. And in many of the European countries, it is actually more than 50%, even 80% in a few countries. Also, we see that heating is dominant. Actually, heating and cooling is dominant actually in all the countries, and not only in the north, as opposed to what you may think. Also, what is interesting to see in our initial mapping is that the cooling share in general is lower than what you would expect. Also, in those countries where you actually use a lot of cooling, we have, for example, Cyprus or Malta or Greece with rather high cooling demands, but still, even in these countries, heating is actually higher. You can go onto our website and learn more about your country. So that was the status. And then the question is, what is it actually that we're looking into in the future? In the European Union, in member states, and in cities across Europe, we are trying to align to some long-term targets within the debate about climate change. And it's clear that the European Union put the target of 80 to 95% reductions in the CO2 emissions from the energy sector. Also, if you look at the graph here on your right, you can see the division between some of the different demands. And as I said before, heating and cooling is 40 to 50% of the total demand. And actually, this also means that electricity is a smaller part and transport is a smaller part. That's the long-term target. Then there are also short-term targets, and we have in the what's called the Energy Union 5 different focus areas. One is the security of supply, solidarity, and trust within the European Union, and this is mainly focused on gas, oil, and electricity. The energy efficiency first principle, and then we have the aim of having lower CO2 emissions, and also research and innovation within, for example, energy storage or the set plan, and these kind of elements. What is clear when you read the overall document is that the main focus is actually to diversify within the gas sector and put in renewable energy to the electricity sector. And then for the energy efficiency first principle, the main focus is on the individual building. Although there's a lot of efforts that have been done with regards to putting technical standards on the different products and also standards on buildings, it is clear that the heating sector has been neglected in the past in the work on the overall level. When we start to compile what is term targets, there's also some intermediate targets, and right now the 2030 targets are being debated, and this can actually have a rather large impact on the heating and cooling sector. For 2030, you can see here that the energy efficiency target is I think it's 27% now. It's being debated whether to increase this. We have 40% target on lowering the greenhouse gas emissions, and then we have also the renewable energy target, which is also being debated at the moment. There are some key elements within the policies that are being implemented, and you could say that these are very focused on the different components that I mentioned before. So we have the energy savings, then we have a focus on more electricity into the energy system. This means, for example, to electrify transport. Also, it's mentioned to electrify heating quite a lot. We have a focus on decentral production. We have gas in a transitional period. We have a contribution from nuclear. And then we have a focus on much more renewable energy and reductions in the energy imports and the prices. This means that we have to do a lot more investments, and we have to use less money on fuels. This is clear from the documents coming out also from the Commission. And the Commission expects larger prices on the short term, but then maybe falling prices on the longer term. But it's clear that the reduction targets are technical and economically possible, and I hope that with our project we can make it also even more feasible. We have also seen that in 2016 there was the first EU strategy on heating and cooling, and as it had been neglected somewhat in the past, it was this was the first attempt to have a holistic approach to the heating and cooling sectors and move away from only looking at the individual building, but looking at the building now as part of the energy system. In the heating and cooling strategy, of course, energy savings and energy efficiency is mentioned, but also now we see that district heating is mentioned as this and is a part of this vision for heating and cooling in Europe. Also, an important element in the heating and cooling sector is to acknowledge that there are synergies by looking across sectors within the energy system, meaning that if we can combine electricity with heating and cooling and use the capacities of storages across, this may create a cheaper option. We can also see across Europe that heating and cooling can have actually rather high renewable energy penetrations. And this map here shows you that some countries have a very high penetration of renewable energy within the heating and cooling sector, specifically, for example, in Sweden or in Finland or in some of the Baltic countries. But we also see that some of the countries have very, very low shares of renewable energy within the heating and cooling sector. And the question is why this is, or what could be done to change this. If you look at the statistics, there's also a clear tendency that those countries that have larger shares of district heating are able to diversify the heat supply and have more renewable energy within the heating system compared to those countries that have low shares of renewable energy. So why is the heating sector and cooling sector so hard to change? Well, some of the things are connected to that heating is rather complex. You cannot simply change the legislation around the heat market as you are doing it with regards to the electricity market. Also, heating is tied up in large investments in individual investments in buildings, which means that it requires a complex set of regulatory measures to actually address the heating and cooling sector. Also, heating is very local, which means you have to have some local action. To have local action, you need also to have handles or some framework that you can work on the local level. Heating is long-term, meaning that if you make an investment, you will have to live with that investment for quite some time. Heat savings and district heating, for example, have very large investment costs, and this means that you have to have some security for the institution, utilities, companies who have to invest in that. For the heat savings, the building owner needs some kind of framework to invest in savings at that time when the building is being renovated anyway. Also, when you look at heating and cooling across Europe, it's clear that heating has some cultural differences. There's some different ownership problems or challenges and profit margins around, which means that addressing the heating sector is not easily done on a European level and can even be hard on a national level. The purpose in Heat Roadmap Europe is to create scientific evidence to support long-term strategies from the very local level to the national and EU level, and to empower the transition to a low-carbon energy system towards 2050. Identifying the impact of various alternatives for addressing the heating and cooling sectors. In today's energy system, we have a rather simple structure, you could say. We have a fossil fuel input on the left side here, and then you have some demands on the right side: heating, cooling, electricity, mobility, and then in between you have the conversion. But in the future, we want to put in renewable energy sources, which means that the system becomes somewhat more complex, as we need to have energy storages within the energy system. We need to integrate solar thermal, PV, we need to use biofuels, we need to have electromobility, electric vehicles, we need to use more heat pumps, which will connect, and also the gas sector can have a role. And in Heat Roadmap Europe, we will try to have this holistic approach for a future energy system where we combine the building level savings with the overall system perspectives. This means that in Heat Roadmap Europe, to some extent, we go from the current challenges and overall energy system, which is a high level point of departure. Then we try to dig in, provide knowledge and data and analysis on a rather detailed component technology country level, also providing maps for a significant part of Europe. And then we end up also using this detailed knowledge to have some overall results that can be used at a national or EU level. By having this approach, we're sure to have credibility regarding the data, regarding the analysis. We can provide knowledge on the very local level, but we can also then use this on the national or international EU level to have results for the scenarios going towards 2050. The objective is to remove some of the barriers that we see in the heating and cooling sector by providing and quantifying what is possible. By using this data and knowledge, we try to open up the minds and markets, and we build hopefully new capacity and skills by also getting our results throughout the European Union in different workshops across member states. We try to develop detailed knowledge, create new tools where you can have a look at, for example, what is the current situation in my country, in my city, on the EU level, and what could the future look like in our setting. Who are you? Well, if you are our target audience, you can be quite a few people. So we try to target from the very local and regional level, politicians, civil servants, etc., to the general public and media to enhance the general knowledge of this problem. Then we also try to address industries and consultancies. Of course, going on the top level, policymakers at EU or in national states can also have interests in our results. In addition, association, NGOs, and academia can use this. The aim is to have a pinch grip on this, where we bring knowledge from the bottom, providing detailed data on maps for cities and local stakeholders, for national states, and at the same time have some targeted results on the top level, where we then hopefully can pinch and address the problem. Then we have also here the member states that we're covering. In Heat Roadmap Europe, we are covering around 90% of the European heat demand, where all of the major economies and countries around Europe will be addressed. And we try to have technical outputs for the different countries. We look at profiling, we look at maps, we look at models, we look at technology data, and then we use this to create low carbon heating and cooling strategies for the individual member states. We provide this on a website in videos, workshops, and scientific papers. Within the project, we have a mix of academic institutions. We have several universities. We have the European Commission with the JRC on board, and then we have several companies as well as experts within different technology areas in order to be able to provide the bottom-up and top-down approach that we're looking at. In addition, we have some stakeholders around Europe in our advisory board where we try to test our results and also get inputs about if we're addressing all of the relevant elements within the heating and cooling sector, so that we're sure that we can also have an impact on the different levels that we are aiming at in the project. If we look at our previous knowledge from the series of Heat Roadmap Europe studies, we can see that we're able to provide at least 50% of the heat in Europe with district heating. We can look at this by seeing the energy densities for the different cities, regions, and countries around Europe, and also looking at the different sources of heat, being that waste heat from industry or renewable energy sources. When we look at the data, it is also clear that to provide heat is not only in the north of Europe, it is also many places and significant. When we look at cooling, this is not only in the south, this is actually also in the north. And the reason is that this is both connected to climate and the different types of buildings that we have around Europe, which are different within the different member states. Another key result from previous studies is that we have more excess heat in Europe than all of the heat demand in the different buildings. This means if it was theoretically, it is possible to eliminate all the use of gas or fossil fuels or electricity within the building sector if we were able to extract or collect all the excess heat and supply the building. Of course, this is not possible, and this is why we try to combine our knowledge regarding the energy system and the data for the heat supply with our GIS and energy mapping. Energy efficiency is certainly an important element of the heating and cooling system, but it is also clear that there is in the future some kind of balance between the cost of making further savings and the cost of supplying heating or cooling. And this is the balance that we have found for the overall European level, which is 30 to 50% savings on the heat demand across Europe. And there are previous results for selected member states. But in this project in Heat Roadmap Europe, we will provide this type of knowledge. When we start to combine what we call energy savings at the building level with energy efficiency by using excess heat, we can also see that there are similar savings on the primary energy supply by saving energy within the building and by by providing heat in a more efficient way. This means that a combination of both doing energy savings at the building level and doing another system or having a different energy system design can provide equal amounts of fuel saving. If we then are saving fossil fuels, we can actually save equal amounts of CO2 as well. The positive thing here is that if we redesign the system and combine all of these elements, we can significantly reduce the cost of the energy system as such, and certainly the cost of decarbonizing our heating and cooling supply. So the previous results show that we can reduce the energy consumption significantly, reduce the imports of fossil fuels to the European Union. We can reduce carbon dioxide emission and reduce the energy cost while increasing renewable energy and potentially increasing the number of local jobs within these sectors. We have found this in the 3 previous Heat Roadmap Europe studies, where we have been moving from illuminating different possibilities within using local heat sources through district heating, combining a comprehensive heat strategy with energy savings, and now in the 4th study here, we're moving into low carbon heating and cooling strategies for the 14 member states. So what we try to do is on the very local level is to quantify the energy consumption, the energy costs, and the carbon dioxide emissions. And as I said, the key results will be pathways towards 2050 about what should be done technology-wise, and to what extent is there a balance between using individual solutions, district heating solutions, gas solutions, and energy saving solutions within the building sector. This requires some substantial data and mapping, where we then have a large focus on looking at the potentials to save energy within the building sector and the cost of making these savings. We combine that with looking at maps and identifying different potentials for district heating. We look at the heat sources that we can use locally, and then we identify that on an energy system in order then to make energy system analysis to create detailed hour-by-hour scenarios and strategies on the different member states. Within the project, we have a complex relationship between different energy models. We have some energy models that look at the heating. This is the PETA, the Pan-European Thermal Atlas, and it's the forecast model where we look at buildings and industry in a transition. And then we have another set of tools or models which is looking at the energy system in great detail, which is the JRC EU Times model combined with the Energy Plan Hourly Energy System Analysis model. Using this, we can look at both single years, which is what is being done in the mapping and in the energy plan tool. We can also look at the transition between 2015 and 2050. And then by combining all of these different tools, we're able to make comprehensive, detailed roadmaps. Now I'll try to make some examples for you about what it is that we're actually trying to address. Here is an example of the energy mapping, and here is a map of the Netherlands. And what we provide is on our webpage the Pan-European Thermal Atlas, where you can look at the heating and cooling demands on an interactive in an interactive web page where you can zoom into your region or city or country. So these are one of the layers in the some of the layers in the mapping. We also have mapped the different renewable energy heat sources, for example, potentials for solar thermal, bioenergy, or geothermal. And if we zoom in a bit, we can see here what this means or how this looks on an example for how much district heating is used in the different settings across Europe. Here on the right, you see Copenhagen with more than 90% district heating, and London with 5% district heating. And on the map, it's not district heating that is looked upon, it is actually the energy density in the cities. So what you can see in the purple is parts of the city, 100 by 100 meters, where you use more than 300 terajoules per square kilometer. And then the red dots are areas where you use above 120 terajoules per square kilometer. And this do changes, how feasible it is to do energy savings, how feasible it is to do district heating. And immediately what is striking when you start to look at these maps is that there are really huge similarities across Europe regarding the heating and cooling demands, but there are also huge differences in regards to how much renewables and what kind of solutions there are across the different member states. Another example of some of the key results already obtained is here from the PETA maps, an example from the Netherlands. Here we can identify heat demands of around 300 petajoules per year, and we have excess heat in the Netherlands to actually cover almost twice that much. Of course, this excess heat is concentrated in a few areas, and you can go into our maps and identify whether your area has a large excess heat potential. But looking at the overall level, it is counterintuitive that a country like the Netherlands does not have a higher district heating share, knowing that the excess heat demand is so extremely high. Another part of the energy mapping is the possibility to use the what we call the heat synergy regions, meaning areas with a large demand of heat and a large potential for excess heat sources, and to look at how much the costs actually could be for creating new networks. In the coming months, in the HydroMap Europe project, we will be extending these options to not only look at the costs of this one technology, but actually looking at how does the local area look when we see towards 2050 with the different elements that we are analyzing on a more energy system level. The other parts of the project is profiling the energy demand. In the beginning of the webinar, I showed you some details regarding the heating and cooling as part of the overall system. But if you go to our webpage, you can find country profiles for the 14 EU countries with the highest heat demand, and have a look at how many, what does the heat supply look like for the residential sector, or the services sector, or for industrial sector. What are the different possibilities, or what are the different technologies being used, And there's also reports regarding how the heating and cooling demands are expected to develop towards 2030 and 2050. In the project, we are also have quite a significant focus on energy savings, and here we are doing on what are actually the costs of doing savings within the different buildings in the different member states. So for all of the 14 countries, there has been created what we call cost curves for reducing the demand in buildings and industry. And this means that we can use this data for the costs of the different options for reducing the demand and combine this with the energy system analysis for actually supplying heat or electricity for these sectors. And when we have the results, we will try to identify some balances between how many savings, additional savings, should be done compared to. Overall, it can be extremely hard to know in which direction everything is going. Will there be new technologies? What will be the role of combined heat and power? What is the role of insulation? Should we produce hydrogen to push out the natural gas in the heating sector? What about biomass boilers or smart grids? And some of these questions are those that we are trying to address with the different set of scenarios and analysis we're doing for the 14 countries in the Heat Roadmap Europe studies. To bring you some examples of why it is necessary to look into not only the heating sector as a sector, but to look at this as to have a more holistic approach. We can look at this overview of the different infrastructures in the energy system. And here you can see the division into resources, electricity, heating, and cooling. And when you have this overview, you can also identify the full costs of the system. If we take the example of heating, you can see that heating is on the right, bottom right here. And what we can see is that in the future, or right now, we're using boilers or fossil fuels to provide heat for the buildings, and to some extent there are some thermal storages also involved. In the future, we will most likely use a lot more wind, which means that the electricity sector will be engaged, and we can start to stop some of the burning of fossil fuels, which means that the different components outside the actual heating sector will be depending on how we use heat and what kind of infrastructure we have on the individual level. For cooling, we can look at the same kind of components where currently we're using electricity to heat pumps. And in the future, what we want to try and provide is more renewable into the heat sector or into the electricity grid, and then to use this example also in combination with storages. When we have these components in the system, it also becomes important not only to look at what happens between now and 2050, but also to understand what happens within the actual year, not only in the year, the month, or the week, but hour by hour within the year. This is necessary to understand the role of the different components. The option to store, for example, heat when there's wind energy, and to use heat in the buildings when there's no wind. And it becomes very important when we look at the balances between energy savings and the energy supply. From the past studies, we have so far on the overall level identified huge potentials for doing savings. And as I said before, 30 to 50% on the overall level is recommended. Then you can divide between urban areas and rural areas, and we can see that in urban areas we should have more district heating. This is where you have high heat densities, you have a neighbor, you can see your neighbor, and in this regard the overall results are that at least 50% of the heat demand can be provided by district heating. In rural areas, it is recommended to have electric heat pumps, and electric heat pumps go well hand in hand also with having a well-insulated house. Then you increase the efficiency within the heat pumps. And then there could be smaller shares of solar thermal and biomass boilers as well, and that should supply the remaining part of the heat demand.
Well, thank you, Brian, for your thorough presentation. I would like to see if there are any comments or questions from the audience. Here's one saying, what would be required to establish district heating energy systems in London? And what would be the challenge?
Yeah, I think one of the major challenges in London is to understand where to start, and I think it would be necessary to identify good heat sources and to identify key institutions, buildings where there is a large heat demand. I think already now the London authorities are looking into different projects where they're trying to build district heating within London. I think it's important to start on a very local level, but to prepare those demo sites and those infrastructures that you build for the future, so that they may be expanded if it is a success, and the rest of London would also want to copy this. I think for the London case is rather interesting, because looking at London is an example for many different parts of Europe. It is clear that if we imagine that we should have renewable energy replacing the current gas heat supply in London, it would require quite significant amounts of electricity, and also it would require to expand the electricity grid substantially. And I think this means that if you want to cost effectively decarbonize your heat supply in a city like London and many other places like it, you need to combine energy savings and energy efficiency within the buildings with a long-term strategy for expanding a district heating grid.
Well, we have another one.
How accurate is the calculations of the excess heat potential? Well, that's a good question, and I think it also illuminates what kind of data it is that we are able to provide. When you look at our results on the national level or go into our maps, the idea is that we have collected the data that is available with the precision of those who collected it. So we are actually using public data to identify both the heat demands locally and the excess heat potentials. And this means that the accuracy of the excess heat potential is only as accurate as the data that we have. For me, it's clear that the amount of excess heat is rather large. Whether it is like very accurate on the very local level where you may go in is something that you would have to investigate before you start. But you can regard our potentials and our local mapping as a screening tool for identifying that there is a possibility that you could change your heat supply.
Well, there's one more. What are your assumptions for heat pumps? Different technologies have varying efficiency degrees, and therefore different costs for consumers, as well as different investment costs, of course. So, I would like to remind that we have a webinar dedicated to heat pumps. That will be in number 4. But what is your comment on this, Brian?
I think there's a lot of different assumptions for that you can make on heat pumps. We have two main categories of heat pumps. We have the individual heat pumps, and then we have large-scale heat pumps that can be used in the district heating grid. I think it's clear that that there are different assumptions you can make, or different empirical knowledge about the efficiency or the COP of the heat pumps that we can use. We will try to use the best available knowledge regarding individual and large scale heat pumps, also including consideration about cooling media, etc. But I think the costs, which you also refer to in the questions that you have, will be depending on the data that we have collected for each technology. What we will try to do is to make some sensitivity analysis regarding different key assumptions in order to also be sure that we have robust results. And for heat pumps, we could also consider to do a sensitivity analysis for the efficiency or the COP. Regarding whether the heat pumps are renewable or not, and this is why we actually look at the entire system, so that we're sure that we know what kind of electricity is being used. Specifically, it's important when you start to put in electricity into the heat sector to have a temporal look at the energy system, meaning that you have to look at when is the heat demand compared to when the different renewable energy sources are there. We have another one saying you showed an increasing gap between the current climate policy pathway in comparison to the 2050 target of the EU. What are the most needed policy steps for heating and cooling in the next 5 years from your perspective to stay on track for the 2050 target? I think there are several issues that should be addressed. I think that the different member states on the EU level have to actually document what kind of strategy they have for decarbonize the energy system is extremely good. But I also think that the European heating and cooling strategies should be improved, and more measures should be taken within this area, because right now what the focus is is on tightening different technology standards for boilers or heat pumps, and it is on improving the internal market by providing knowledge about how the market can be designed, or also to build electricity infrastructure or gas infrastructure. And I think a lot more has to be done on building also thermal infrastructure in the coming years. And I think to have a follow-up on the European heating and cooling strategy would be a very good idea.
And now the last question we'll take. How do you differentiate from retrofit scenarios for building efficiencies versus new builds? New builds can implement deeper energy efficiency designs that are economically possible for the retrofit scenario.
There are different assumptions within the data we use regarding how many new buildings are being built, or what is the demolition rate, and what is then the possibility to improve the efficiency of the different buildings. And to some extent, you could say that this could be affected by policy. So if you want to remove the worst buildings that are not worthy of keeping, then it would be a good idea to replace these with new buildings. But when we look at the data, it is clear that even disregarding new builds and demolition rates, it's extremely important that when people have a chance to spend a little extra money when they are actually renovating their building, to then install new technologies that are more energy efficiency, is extremely important if we want to reduce and the demands and decarbonize the heating and cooling sector.
Well, thank you all for your participation. The recording of this webinar will be soon available on our website and our YouTube channel. We look forward to having you at our next webinar on the 22nd of March, where Ben Moller from Flensburg University will speak about energy mapping and elaborate on what Brianna introduced us today. And last but not least, you can register as well for free for the rest of the webinars in our website. And before we end, I would like to invite you to our upcoming workshop about modeling and scenarios, which will take place in Amsterdam next week. You can register for free and have the chance to meet the people behind the Heat Map Europe project. Thank you for attending, and have a nice afternoon.